All right, guys, here it is, your very last video for your very last lesson of your semester that was half in person and half online. We're just doing projectile motion, and here's the thing. Yes, we're doing this with parametric equations. We are only lightly touching on this. We're not going into any big detail on this. And in all honesty, guys, they're just fancy quadratics. That's really all it is. It's just fancy quadratics. It's quadratics that we write with respect to time. Instead of us writing, y equals, I don't know, it doesn't matter. Y equals 3x squared plus 2x. Actually, it should be a negative 3x squared plus 2x plus 1. It doesn't matter. Like, instead of us writing a parabola that has, distance from where we fired the cannon and our height, how high is the cannon from how far, how high is the cannonball from how far away the cannon, blah, 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 blah. Sorry. Instead of us writing it like that, we're going to write it with respect to time. So our time is going to be our horizontal axis. And we're going to say, okay, at this point, it is, this many feet away and this many feet in the air. And it's just fancy. It's just fancy parabolas, really is what it is. Fancy quadratics. So your set of parameters is going to be x equals v naught cosine theta t, y equals negative 1/2 gt squared plus v naught sine theta t plus h, where your v naught is initial velocity, your g is your acceleration due to gravity, and it is 9.8 meters per second squared, or 32 feet per second squared, depending on whether or not you've got stuff in meters or feet. And then, of course, your h is your initial height. Okay? All right, a cannonball is fired across a flat field at an angle of 45 degrees with an initial speed of 32 meters per second and an initial height of 13 meters. So when we're looking at this, our theta is going to be 45 degrees. Our v naught is going to be 32 meters per second. Our height, our initial height, h equals 13. And then our g is going to be 9.8 meters per second squared because our height and our initial speed are in meters. So when you're doing this, the first part, write a set of parametric equations for the motion of the cannonball. So the first one. First one, we've got x, oopsies, sorry. I grabbed the highlighter and not the pen. Sorry about that, guys. X equals 32 times the cosine of 45 times t, right? And I'm just straight up using the formulas from the previous screen. So x is going to be, and here's the thing, I don't remember what my math lab is going to do, as if it's going to make you write it as in simplest radical form, or if it's going to want you to round. I'm just going to write it in simplest radical form for now. 16 radical 2 times t, because remember cosine of 45 is radical 2 over 2. And of course, if you want a decimal, just pay attention to what my math lab wants. Your y is going to be negative 1/2 times 9.8 t squared plus 32 times the sine of 45 times t. And that's like, that whole thing is going to be one number. And then plus my 13. And guys, I'm so sorry. I always forget that my t's and my plus signs look the same. I do apologize. So negative 4.9 t squared plus, I'll try to make them look different, 16 radical 2 t plus 13. And again, decimal is fine for the 16 radical 2. Just pay attention to what it's asking in your My Math Lab. All right, so the second one, determine how long the cannonball was in the air. So really, it's asking you, where does y equal 0? Okay, where does y equal 0, right? Because if y is still going to represent our height, okay? So 0 would be on the ground. So Couple ways you can do this. You can plug it into your calculator and you can get it from there if you want to. You can do, I'm just going to do the quadratic formula real quick. And I do mean really quick. So when I'm doing this, we'll go, not that color, we're going to go, sure, we'll go yellow. So, because you would just take 0 and put that 0 here. Again, you goof. I keep going for the highlighter. So we're really just saying, hey, 0 equals that whole thing. So you can just use quadratic formula for you, but it's not going to be x this time, it's going to be t. So t equals the opposite of b, so negative 16 radical 2, plus or minus the square root of 16 radical 2 quantity squared minus 4 times the negative 4.9 times the 13 all over 2 times the negative 4.9. Okay, so this is crazy and super, super duper messy looking, but that's all right. So negative 16 radical 2 plus or minus. Underneath all of that radical gives me 27.69 divided by negative 9.8. Now what I'm going to do is if I did negative 16 radical 2 plus 27.69, I'd get a positive number in the numerator, and then I'd have to divide it by a negative. So that's not really what I want. I want to take the minus. So when I do that, what I'll get is 5.13 seconds. So it's in the air for 5.13 seconds. Okay. Part 3 is asking, determine how far the cannonball traveled in the air. So really it's asking for the x value, right? And so what we're going to do is we're going to use our formula right there. I'm going to undo it now that okay. And what you're doing is you're plugging in the actual time that it was in the air into that formula. Okay. So x equals 16 radical 2 times the 5.13. And so that is 116.2 meters. I have to shrink this so I can still write because I'm running out of space. Sorry, oops. I hate it when it's not like all connected. Drives me nuts. Okay. And we'll shrink a little bit more. All right. Then part 4 is asking, all right, calm down there, Cletus. There we go. So part 4 is saying, hey, determine when the cannonball reached its maximum height. Guys, max and min for parabolas, those were your vertices. No, not vertices, vertex. Sorry, there's only one. So you're used to seeing x equals negative b over 2a. Well, it's literally going to be the same thing, but instead of x, it's going to be, good grief, t equals negative b over 2a. And so when you do that, that'll give you the time that you reach your vertex. So negative 16 radical 2 over 2 times the negative 4.9. When you plug that whole thing into your calculator, you get 2.31 seconds. And please remember, please remember that you are not allowed to just take the, let's go purple so it highlights. No, let's go aqua. You are not allowed to take this time and cut it in half. Do you remember why you can't do that? It is because you have an actual initial height right here. If your initial height was indeed 0, then yes, you could take the time that it was in the air, cut it in half, and that would be the time that it took to reach your vertex. However, anytime you have an initial height that is not equal to 0, you can't do that. By the way, you could do all of this stuff with like completing the square too if you wanted to get it in vertex form, but honestly, unless we're going to graph something, I don't really see the point of that. And actually, yeah, I don't. All right, so then that is 2.31 seconds. Sorry, I know I was rambling and I know I went off on a diatribe, but I just needed to remind you guys that that 2.31 seconds is not half of that. Okay? I mean, to be fair, it is actually kind of really close. Because 5 is, well, it'd be, well, no. It'd be 2.5. No, it's not. Never mind. Okay. Again, and it's actually good that it's less than it'd be 2.52 6. So it's less than that, so that's good. So yeah, no, we're okay. Again, rambling. Sorry, I will finish this so you're done. Sorry. All right, so there for part 5, determine the maximum height reached by the cannonball. So what you're going to do is you're going to take your time and you are actually going to plug it into here and here, right? So that you can actually find that. Guys, I'm not going to write that out as long as you don't mind, because it's really just plugging it in there, and you'll just go to your calculator to do that. So it's really going to be 39.12 meters. Okay, sorry for the rambling. Sorry for going off on my diatribe. That's it. You're done. Woohoo!